With the cylinder on the mandrel and the mandrel in the collet block, I can square it up with the 1, 2, 3 blocks and rotate to put the face upwards. This is setup 2, the lathe being setup 1. And there's 4 different operations we can do here, and that's being generous. Operation 1 of 18 total on the cylinder is to face the steam chest. Using a 3/4 inch end mill at about 750 RPM, touch off initially, and then do about 8 passes, about a 1/10 depth of cut to get down to the finished dimension. Note the invisible machinist jack that I'm using to support the otherwise unsupported end, because if it was unsupported, that would be bad, and bad things might happen, but I've heard that the invisible brand of machinist jack are excellent and very cheap. If you're enjoying this build diary, please like and subscribe. If you have any questions or comments, please add them in the comments below. Thank you for watching. Operation 2 is to mill out the steam chest cavity using a 1/4 inch end mill, because we have a maximum of 1/8 inch radius on the outside. This takes several passes. And I was doing about 10 thou or 20 thou per pass, and I thought I'd go a little bit faster and go up to 30 thou. This was a little bit too much for the invisible machinist jack. Wait for it. There we go. Did you see that? No? Okay, there it is again. Okay. So it also cuts a little bit of metal off the back. Luckily, it means it's not getting to the full depth. So rather than taking off too much metal, I'm taking off too little metal, which is always easier to recover from. Took me a while to notice there was a problem. There it is. It's not square anymore. Oops. So, using any other brand of machinist jack is better than using the invisible brand. Do not take those for free, or even pay for them. But we finally got to the end of the cavity and switched to the 1/8 inch end mill, which is needed for the next op, and making the corners slightly sharper and everything a little bit shinier. The next op is the valve ports. There's actually 3 valve ports in 2 different sizes, so this is really 2 or 3 different operations. This is a simple ramp down to a 3/16 inch depth from the bottom of the cavity, just zigzagging down, going down 10 in a diagonal and then straight across. I think it's 18 times total. So this is at actual speed, just to see how long this sort of thing actually takes. And there's only one of these. The other 2 ports are 0.2 inch off to either side and use a 3/32 end mill. And those I sped up. You can see this one, I didn't film the other one because the camera there was no way to actually get the camera in there to film it. You could kind of see what's going on here. And then we have our 8 little holes. These are 256. You've seen these before, using a G83 to go around, and they're going to a 1/4 inch depth for the 2 blind holes, and the other holes are also going to 1/4 inch depth, but the metal isn't that thick, so those are through holes. I'm never sure if tapping fluid is needed for bronze, but it doesn't hurt to use a few drops here and there. There really is no good way to film this without getting my fingers in the way, at least not with my equipment. My apologies. Continue to admire my fingers. The reason I speed the tapping up is because this is how slow it actually takes. Just to do these 8 holes, and 2 of them have to be done twice because of the bottoming, would take 2 or 3 times the length of this entire video. If you have the patience for that, or you're really enthusiastic about things like watching paint drying, I've got the footage, I can put it up, but I suspect that people will change the channel. But, you know, specialty tastes. That completes the operations on the steam chest. The next operations will be setups 3 and 4, which will be the top and bottom faces. Thanks for watching. Please like and subscribe.